All right. Okay, so today I'm going to be talking about event sourcing from scratch with Apache, Kafka, and Spring. In the abstract, which I just reused from Spring 1, which is a talk that I gave with Jakub. Jakub is now joining Pivotal on my team, so I'm very excited about that, but he's from Poland. And we did a talk together on this subject for that abstract, and I've changed things since then considerably because I usually would need Jakub for that talk because it's a student-teacher dialogue. And so this is all new content. By the way, my name's Kenny Bastani, Spring Developer Advocate at Pivotal, and I'm from Silicon Valley. I wrote a book with Josh Long called Cloud Native Java. So the agenda is, first, I want to talk about history, because I found some interesting connections with event sourcing throughout history. And it's kind of funny because event sourcing really just tells a history. And so I wanted to kind of take that approach to event sourcing because actually, if you look back far enough, there's a lot of references to event sourcing from people you wouldn't expect. And so we're going to talk about that. And then we're going to build stuff. We're going to build an event source system with Kafka and Spring Boot. Some unscripted audience-driven live coding will be a part of this, so don't fall asleep. Okay, so here's the warning. This is all new content, well, mostly new content, and it's the first time I'm doing this talk, so things might blow up. Actually, things will likely blow up, and thanks in advance for not throwing tomatoes. Okay, so event sourcing, a mystery, a history. All right, so event sourcing's origin story goes all the way back to Edgar Allan Poe, who is a poet. Who's heard of Edgar Allan Poe? Okay, great. Okay, so he wrote in a poem this statement. So I thought this was actually pretty striking. And so I did some more research on Poe, and it turns out like he was an event sourcing guru. And so he said, "We appreciate time by events alone. For this reason, we define time, somewhat improperly, as the succession of events. But the fact itself that events are our sole means of appreciating time leads to the erroneous idea that events are time, that the more numerous the events, the longer the time, and the converse." So, the question we should answer is, did Edgar Allan Poe invent event sourcing? What do you guys think? No. But it's interesting. It's really interesting, so I did more research on it. It actually goes back to the chip log. Who's heard of the chip log? Wow, really? No one. This is exciting. Okay, so the chip log, actually, mostly every single metaphor that we use today in terms of logging, in computer science, software in general, came from this very system. Now, the word log goes all the way back 2,000 years ago, and it means word. In the 15th and 16th century, there was no way to measure the speed of ships, right? So they didn't know how fast they were going, which means that they didn't really have a good idea before the chip log of how soon they were going to arrive at their destination, right? Today we have GPS, and we take all these things for granted. Now, the chip log is an interesting device that resembles a lot of the stuff we're doing today. Okay, here's the ocean. That's a ship. I drew this, by the way. It's horrible. And so this is kind of like a fishing reel, right? So this chip log, what the sailors would do back then is they would unwind this reel and let it drag in the water. And so you see these knots here. This is a rope. It's called a log line. It's like a fishing line. And here's the knots. Now, you may be familiar with the term knots as a way to measure the speed of vessels that are sailing on the sea. And so this is actually where it comes from. Now we have electronic devices to measure this. But what they would do is they would just let this log line unreel in the ocean, and they would have an underwater parachute that would just drag this along and unwind that reel. And then when they wanted to measure their speed, they would reel it back in, and they would count the number of knots on the rope, and they would approximate how fast they were going. Now, since I did a horrible job at explaining this, I have a video. And it's about 2.5 minutes. Tyler's going to play it for us, hopefully. Cool.
This is how you can tell how fast the boat's going. How do you tell how fast the boat's going? What's that thing your dad's always walking around playing with? That little black box you won't put down. Not the camera, the other one. It's the GPS, right?
Yeah.
Okay, that's how your dad knows how fast the boat's going. Good. But back in the old days, like 200 years ago, they didn't have that, right?
Yeah, so they had to use
So this, right? Okay, this is how this works. This is like an underwater parachute. So hold it. right? So you throw that in the water in a minute, and the boat's going to sail away from it, right? And the faster the boat's sailing, the faster the line's going to come off, right? Okay, so the faster the boat's going, the more string is going to come off, right? Yeah, we're going to.
Right now?
Yeah, in just a second. So, you know how, like, you measure your speed in knots? You say we're going 5 knots? Okay, check it out. There's actually knots tied in the line. Okay? So, you count knots by how many knots pass you during 14 seconds, okay? So we're going to throw it over, we're going to count to 14, and then we're going to see how many knots pass us, okay? And that'll be how fast we're going. All right, Dante, toss that in the water.
There it goes.
Right there. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, it used it all. Perfect. All right. Now pull it in, Dante.
Okay.
It's hard, huh? A lot of load on there.
It's coming. I just got it. The
So, Dante, count the number of knots that we pass up, okay? Every time there's a knot in the line, you
One.
know. You found one?
Yeah.
All right, good. There's one.
2.
2. All
2
right.
of them. 3 coming up. God.
You can do like
9 knots past us.
this one right here doesn't count either. All right.
Okay, closer to 5.5. And so that's it. And so that's where we get the term for logging in computer science. So I had to answer this question when I was going back and looking at the history of event sourcing. I was actually writing a blog on it, and I wanted to see where all this stuff came from, because it's kind of interesting, event sourcing as a way to actually collect state with our data and represent state as a collection of events. And I thought there was an interesting story there, and I didn't know where the term log came from. And I say log in a general sense for all system logging. And so we have to go back to Poe. And so Poe actually was obsessed with the idea of event sourcing. Who knows what event sourcing is, by the way? I should probably just define it. No one. Okay. So event sourcing in computer science, it goes back to Martin Fowler back in around 2006. He described a system that allows you to store state as an event, a series of events. And so if you have an account and the account has multiple statuses, let's say the status is active, let's say it's suspended, confirmed, those statuses, what we do today is we store them as a column in a database, right? And we just overwrite. Every time we change something, we just overwrite that field. And so the idea of event sourcing is that we're going to store these things as a collection of events. Every time you change the state of the system, every time you apply a command like activate account, then you're going to see an event in that log as account activated. And so that's the idea of event sourcing. And so, like I said, new content, so I should probably define that first next time. But it goes back to Edgar Allan Poe because he actually knew about this system, and I think he was so depressed all the time because nobody knew what he was talking about. And that makes sense. So Poe was obsessed with the idea of event sourcing. He talks about it a lot in most of his works. But in his time, things were commonly measured using a form of event sourcing, right? Back then, they didn't have this idea of you can just store things, you'd store their value. You had to store things as a collection of events. And so just like the knots on the log line for measuring the speed of ships, he saw this idea as fundamental to our entire universe, the way that atoms interacted. But most software today is built on metaphors, mostly all of software, right? You have the desktop, and I have a word cloud here. But the problem is that we've forgotten the meaning of these metaphors. And so we have words, things like serverless, that just make no sense. And so I'm not going to read this whole thing, but if you are interested, I think I posted this on Twitter today, Poe proves that he understands this idea of event sourcing as the succession of events. And so what it is really is that when you're event sourcing, an event source system uses this term aggregation, which takes causal events across space and time and summarizes them as a single object that's easier to store in memory, and you can pass it around. And the reason why we are talking about this today is because in the world of the monolith, we didn't really have to worry about that too much. But when you go over the boundaries of the network, when you have a distributed system, you need a way to pass around these objects. And since you have eventual consistency, you have no strong guarantees that everything in the system is going to be consistent at the same time. And so the idea of event sourcing is becoming popular because it's a way to keep consistency globally across your microservices. So Poe really was just a master of language, metaphor, and abstraction. So he understood these things, and all of these words that we're using in computer science, in a way, he actually puts these in his poems. So he understood the method of computation through language before computers existed. I thought that was fascinating. But then I read this too. He says, an artist will always contrive to weave his illustrations into the metaphorical form. And all great software really is built on metaphors. So I just, at the top of my head, I just threw down a bunch of terms that were metaphors that we use in computing. And I noticed that I didn't think of things like microservices, SOA, ESB, and a lot of those terms actually, it turned out that they were very confusing, and the implementations for these things ended up also being very confusing and convoluted. I thought that was interesting. So these metaphors mean something, right? There's an underlying abstraction to our own humanity, and it has some intimate connection to the virtual world we're building. It has to mean something in real life for us to really be able to explain it to other people. When new people come into the industry or they go to school, if they don't really have these metaphors, then it's going to be very difficult for them to understand what something does. Now, over time, what happens, because Martin Fowler's our only historian in software, we don't really understand how these things from 10 years ago or 20 years ago are supposed to be implemented today because the original meaning has dissipated. It's gone. It's hard to put it back together. And so going back to the desktop computer, what it did is it replaced actual desktops by replacing this abstract functionality of the desktop underneath the desktop, right? So you have files, you have a bunch of stuff. I listed it. But now if you take that forward, this is happening much faster. The virtual machine itself replaced the server by virtualizing the abstract functionality of the hardware. And you could take this further by saying that the Linux container replaced the virtual machine by whatever. But ultimately, it's hard to keep track of all the layers, right? So we're just building layer on top of layer, and eventually we just lose the metaphors. And so we get lost in the abstraction. And I like to say that all confusing software is really built on nonsense. Serverless, we have servers, right? We still have servers in serverless. And a lot of people today are arguing about just the meaning of the word. They're not really understanding the architecture. And a lot of those people, they're not actually building these systems. They're marketers. And these marketers, they don't really know how all this stuff works, right? So that the only thing that they really have are these words to relate to. And all they're going to argue about is whether or not there's actual servers involved. Middleware is another one. Microservices. Microservices are good, I think. ESB, NoSQL, SOA, all these things, kind of in a way, there's some argument about their meaning, right? Oh, this one too is very important, DevOps. And so we find ourselves often, or a lot of the speakers at conferences are really arguing about these terms because they're not really metaphors into anything. There's no apparent meaning there. So I'm not saying that microservices and serverless are bad by themselves or nonsense. I'm saying that metaphors make good ideas more durable to nonsensical interpretation. And event sourcing is key to that, right? If you think about today, when we're storing state in a system, we don't understand behavior, right? The behavior of our users is based on the actions, the commands that they've taken in the system. And so we're really just pasting over that, right? We're just storing the current state whenever we need to change it. So going back to the chip log, what the metaphor is today for event sourcing is this idea of the immutable log, right? The immutable log is something that Apache Kafka uses at the core of their architecture. But in all databases, you have a transaction log. And that transaction log is a time-ordered series of events. And if you replay these events, you get the current state of the database. And that's how HA databases work, highly available databases. These clusters, the way that they replicate data is that they use this one source of truth, this log, and they replicate it out. But they don't just transfer that data. They're transferring the operations. And they're running those operations in the same order, and that's how you get a replicated database. So that's a log. This is a log. Also a log. I don't know. I just threw this one in. OK. So Apache Kafka, the immutable log as the source of truth. So we have these time-ordered events, right? So these events are always going to happen in the same order. And if you replay them one by one, you're going to get the current state of a system. And that's how Apache Kafka works, is at the very core of Apache Kafka, you have this replicated immutable log. And the guarantees that they provide, they say that since there's just one Apache Kafka cluster, the order that these events are received are the order they're going to be put in the log. And so with microservices, the main problem is that when you store data that's related to time, the time is going to differ across these different microservices and across these different databases that are attached to these microservices. And so the main idea behind Apache Kafka is that you're going to store state as a log of events, which is very similar to the log line that was the original metaphor of the log in computer science. So event sourcing isn't just a good idea, it's actually fundamental to how computers work. Alan Turing saw this also as a series of events, and he came up with this idea called a Turing machine today. And what it does, it processes a set of events in order, as really just operations. And so this is a very confusing diagram that I put together, but we'll try and walk through it. You have a state table, right? And that state table, you have state X and you have state Y. And you have these binary numbers, and that's our data, right? So these bits represent our data, and a Turing machine, what it'll do is it'll process these numbers in order, and depending on its current state, it'll take a certain action, right? So if it reads in for state X, 0, it's going to write a 1, and then it's going to move left. And then the next state is Y. So then it goes to the Y state table and says, okay, if the next number is a 0, then write a 0 and move left and change to state X. And so that's how all computers today work. That's how computing at the very core, the lowest layer of abstraction, works. And so the events are really fundamental to how we process data. And I thought this was a good illustration. I think the easiest metaphor here is just that, like, if you want to think about your data and the way that you store it in a relational database, when you're overwriting data, you're not really storing that history. And so it's like one musical note in a symphony versus an entire symphony, right? So if you think about the value there that you can capture for a business, being able to see the entire history of behavior of all of your users, it's a very powerful thing. So why aren't we doing it everywhere? That's the question, right? Why aren't we already doing this? Well, we are in a lot of cases, but when it comes to building applications, enterprise software, we're not doing it because it used to be very costly. Because storing state as an immutable log of events for domain data didn't make sense in a time BC, before cloud. So today it's a lot cheaper to spin up instances, virtual machines, right in the cloud. And so you don't really have the same constraints that you had in the monolith, where it was very expensive to modify the database, right? So modifying the database, even database backups, like there was a lot of convoluted process involved with our data. But today it gets a lot easier because we have things like Apache Kafka. Apache Kafka actually handles this for us. We don't have to worry about it. And so it makes a lot of sense today to use Apache Kafka to do this. And that's why I think Apache Kafka isn't just a trend. It's actually going to do very, very well. And so the way that this works for our services, this is from Confluent, who is the maintainer of Apache Kafka. What they say is, okay, here's your order service, and it has a database and an event, right? So for integration, events, we've always used those as messages. But you also have a database where you're storing your domain data. And you're just replacing that data every time you change the state. So Apache Kafka says, well, you don't really need that database if you can derive state solely from the events and if you can snapshot it. And so Apache Kafka has an interesting architecture. It's not quite a database and it's not quite a message broker. It's kind of both. And so with Kafka Streams, it's going to have a database and it's going to have that log. And so as you're passing messages into the system, it's going to order them, right, for you in this log. It's also going to allow you to replay these events to create a snapshot. And so you really have everything you need here to actually have a database. Now, I'm a fan of a lot of different databases. I like Neo4j. I used to work there. So I like the idea of connected data. So I think that Apache Kafka will eventually play well with these other systems. All right, so why now? Why are events a big deal? I think I kind of answered that, but microservices, right? So that's why we've come back to it. That's why Apache Kafka is starting to become popular, is because with microservices, we have to handle data consistency somehow. And the best way to do that is to make sure you never lose any data, never lose the information of how that data changed, right? So if something happens, something horrible happens, you could always go back and replay those events and generate the current state of the system. All right, so we're going to build an event-sourced app with Spring Boot. You guys know what Spring Boot is, I'm pretty sure. So I'm just going to go to start.spring.io, and let's create a simple event-sourced app. This is not going to use Kafka. It's actually going to be a monolith, but it shows the idea of how to create an event-sourced system. And so I'm going to name this, actually it's up to you. I have a script here, since it's the first time I'm doing it. So there's this thing called event storming, which is this process in domain-driven design that analyzes the behavior of the people you're building your application for, the business users, who are the experts, the subject matter experts. And really how it works is you start with a domain object, let's say an account. And then you describe the behaviors of what happens to that account. And those behaviors are really commands. So you capture those as commands, and then you can generate your events. And so I'm going to have you guys come up with the domain. All right, who wants to be brave and come up with a domain? Example domain. I have a circuit breaker here. Cheat sheet in case the audience is sleeping. All right, so an account. So we're going to go with an account. So an account, what you can do to it, you can do three things. You can create an account, you can activate an account, and you can suspend an account. And that's going to generate events, pending, active, and suspended. And there's going to be a state machine, kind of like what Alan Turing came up with. But depending on the current state that you're in, you can only advance to a certain number of states, right? So if you're pending, then you can only go to active. You can't go to suspended. If you're active, then you can only go to suspended. If you're suspended, you can only go to active. And that's a state machine. I didn't finish this in the car, so I just described it. All right, so what we're going to do is we're going to build a basic Spring Boot application. We're going to build event sourcing from scratch. We're going to start with account service. And we need a few things. We're going to need to be a web application. We're going to need Spring Data JPA, so I'm just going to connect it to a relational database. I'm going to choose H2, which is an in-memory database, which makes it easy to build for a demo. Let's go ahead and add a few other things. REST repositories, actuator. I think that's it. OK. All right, so I'm going to open this up in IntelliJ. All right, so the first thing we're going to need is we're going to need an account object. That's going to be our aggregate root. So I will describe that as a class. And I'm going to do this a little bit fast. I assume most of you know what I'm doing here. So the account's going to be our JPA entity. And we're going to give it a primary key. And ID, generated value. And then we need a couple fields. So for an account, let's say that I have an account number. And then I'm going to need some kind of status field. Okay, so let's call that account status. And I'm going to create that as an enum. And we have a few different states, right? So if you go back to what I wrote earlier, we have these commands which we're going to create. So I have the create command, activate, and suspend. And these events here, these are actually going to be events, but we can actually capture those as the status of the account as well. And so we're going to have three statuses. We'll have pending, active, and suspended. Easy enough. Now, typically, we'd be kind of done here with this entity. We would have to add some public getters and setters. But when we save an account, usually we're just going to overwrite that status. But in this case, we're going to derive the current status of the account from a collection of events. And so we'll process them in order. And so the next thing I need is to finish the account. And create a constructor. And some getters and setters. Okay. All right, so now we have our account object. I'm just going to run the application real quick. Actually, we need a repository first. So the next thing I need is a repository with Spring Data JPA, and so I'll do that, account repository, and extends JPA repository for account and integer. Okay, so now I'm going to go ahead and start the application up just to make sure I didn't screw up. And that'll start on port 8080. All right, cool. All right, so now we have, so this is our hypermedia response. It's just telling me I have my account repository now with Spring Data REST repositories. And I can go to /accounts, and I get back a list of the current accounts. So I can go ahead and create one with a REST client. We had account number and account status pending. Oh yeah, I've done something terribly, terribly wrong. Account num. This is how you actually don't build software this way. It's a really bad idea. But for demos, it's OK. I actually have to put an annotation on status, but we get the idea. I'm actually never going to overwrite the status via the REST API, and so that's fine. We're going to derive the status from a collection of events. And so what we need to do now is really create a controller for this account and create a collection of commands. And so the next step here is to override that Spring Data REST repositories with a class called account controller. All right, so we're going to make this a REST controller, and let's map that to the root. And now we can go ahead and create a couple of methods. We would have basic CRUD operations here. I'm going to go ahead and do a get. So let's do public account, get account. And I'll make this a get mapping. And that'll be at accounts. And I feel like I messed that up. ID. All right, so that's going to be path variable. And Rob, tell me if I get anything wrong here, because I did not practice this. Okay. What? Okay. Okay. So this is going to be, I can actually just do this, integer ID, and then I can use my repository. And always use constructor-based injection. Yeah. Okay, so now what I'm going to do is look up an account, get ID, and I think that'll do. All right, so typically you'd want to wrap this in an optional or do something that's safe for software, but for demos this is okay. So that's our get operation. We're not going to have a put operation because we're not going to be overwriting that data. We're going to have commands. And so the next step here is let's do a create command. So public, we're going to need a command object. So let's say that's going to be create account. And our request body will be, let's just call this a create account command. And let's do that. So now we got to create our command object. And so this command object is just going to be a pretty lightweight POJO. Let's go ahead and put our account in there, or the account data. So there's a couple ways to do this. You can just put the account itself, and that will be easier, or you can put the fields. There's a lot of ways to construct a command. The basic idea is that you know what this command is, and you know what the state machine is, and so you can generate an event from this, and you can come up with the status of the account. And so what I'm going to do here is just wrap this object with an account itself, just for time. So that's going to be private account. And getters and setters. Okay. So now we have the create account command. And so to create an account, what we're going to do is just extract the account from there. So step by step. Ooh, that's not good. Okay, so that's our account object that we're going to save. And just for time, let's go ahead and save it. Okay, so now we can create an account. But we actually want to create an event for this, and we don't have a collection of events that we're saving right now. And so when we process this command, it's going to generate an event. It's going to attach that to the account object. And so the next thing that I'm going to need is a... Oh, yeah. Thanks. All right. And so the next thing that we need is an account event. And so I'm going to create that as... Let's create an object for that. So here's the account event. We're going to need a type of event, so I'll create a type as well. Nope. And that's going to be an enum, and now we can actually put our event types in here, which is pending. Cheat sheet. Pending, active, and suspended. Okay, so those are our types of events, and we have our event object here. So let's initialize that. Getters and setters. Okay. So we're going to also need a repository for our account event, and each account event is going to have a timestamp, and it's also going to have an ID that relates it back to the account. The idea here is that you want to make a connection between your account and then this log of events. And so we're going to have an ID to make it easy, and that's about it. So this needs to be a entity as well. That's auto-generated, so we're going to need I thought this was a bit ambitious, and so I hope that we'll get through this, but please don't throw too many tomatoes at me if I totally mess this up. Also, you could be my pairs, so... Yeah, I do. Okay. All right, so we're going to reference the account that we create with the account number here, but we're also going to need a timestamp. And so we're going to use a long here, timestamp. And let's go ahead and assign that when it gets created. And that'll be new date. Cool. All right, so now I need a repository for my events. And that'll be a JPA repository. Cool. All right, so now I have an account event repository, and I have my account repository. So now what I can do is, let's create some stuff. And so when I go to create account, which is in my controller, we're saving the account itself, but we should also save the event. And so now I need to inject in a reference to account event repository. And I can go ahead and also create my new account event. So that'll be event repository dot save new account event, and then the account type. and it's going to be pending. Right? So when we create the account, it's going to be in a pending state, and then it can only transition to an active state. I think for time, I'm only going to do pending and active, and so the next command that we need is activate account. And in this case, we really don't need anything other than an ID, and so I'm going to do that here. And we'll just name this as activate. Yeah, so this will be a post mapping. All right, and oh, I totally screwed this up. I'm not as good as Josh at this stuff. All right, it's because he does all those spring tips. I should probably do a few of those. Yeah. All right, so integer ID, and I have to do that up here as well. In this case, we don't really need this, but typically what you would do is you would have the ID of the account. So since we really don't have a command per se for an account because we don't have an ID on it, so let's just go ahead and do that. So when you create account at /account, you're going to send your create account object, and that's going to create the ID. So now that I have the ID, now I can actually apply commands to it. And so what I'll do here is I will look up the account. That gets my account, and hopefully there's one available. I would probably put in here, you know, an exception if it didn't exist, but since we're limited on time and I'm not really good at this, we'll just leave it at that. All right, so the next thing is we need to check the status, right? So the current status is going to be get status, and we just want to make sure that it's in the right state. So the status itself in this event sourcing from scratch system is going to be the snapshot on the status field itself. And so we're going to get the account status that it currently has, and then we check to see what it's in. So you can do a switch statement here, or you can just say if the status equals then it can transition to the next state, and so you will set status to active.
So, Ken, just one thing on that.
Yeah.
So you're never actually setting the status on the account object itself when you create it?
Yeah, that's a good point. I need to go back and do that. Very good point. So yes, here I just want to initialize it. Actually, it's probably better just to put it here. Pending. Thank you. All right, cool. I already created a stat. Okay, so you can see how confusing this is already. Now with Apache Kafka, which I'm going to show you a finished example that fully works and it uses Apache Kafka after this, it takes care of a lot of this stuff because it uses a NoSQL database called RockDB, and from there you can actually replay these events and you can store the snapshot. And you can actually just have a repository or a case stream that pulls that back, and you don't really need to do all this extra work. Now I've created examples like this in the past. It's been a while. But it gets pretty convoluted really quick. So you can see how much stuff I already have. This is very bloated by itself. It's almost too much. But this is the basic idea behind it. And so where we're at now is we check the current status of the object. If it does not equal pending, then you can throw an exception. I'm just going to put a comment here. Nope. And so you've set the status to active, and then you can return the account. But you should also save the event as well, so you can go back and replay it. So the next thing you want to do is just make sure when you set it that you set the status in the account event repository. So you'll save a new account event. And I also need to have so that will be active, and I need to put the account number, which will be account.get account num. What? I did it backwards. I do this it's so much better when I'm not on stage doing this. It's just like, all right, so get account number and then account status active. Yeah, so it's confusing because there's the event types and then there's the account status types. All right, so I think we should be all right. All right, so we saved the events, and they're going to have a time stamp for each one. One thing I didn't do here is also need to supply the account number. Okay, cool. Yeah.
I think you also, for the save, since it's auto-generating the ID, you probably need to reassign the account for after the save, unless you're passing that in for the account.
Yeah, it's by the account number.
No,
The account is auto-generated ID, right?
it's a live object, though. You should be fine.
Yeah, it should be okay. So
Any manager should return it.
I'm not going to relate it by its integer ID. I'm going to relate it by its account number, like a logical ID. I think that'll be easier because I'm not going to really, I could assign it here and then I could pull that back and then put it there, but I'm just going to leave it at that for the account number. Okay, so that should be good. We're going to go ahead and start this up, and hopefully it will. Oh yeah, thank you. Okay, cool. So I'm going to start this up, and if it fails, we'll try and fix it. All right, so the API now is going to be at /accounts. So it's the same thing. So we're going to send this to the /accounts URL. But what I need to do is to make sure that I create the JSON that wraps the account. So this will be account. And that should be fine. Cool, so it worked. And so the status is null. That's not good. So let's see why that is. Oh. All right, so yeah, I have to assign this when I create the object. So that's going to be status pending. And we'll iterate. Okay. All right, so that's good. So we have created the account. It's in a status that's pending. We should have stored the event as well. So the next thing I'm going to do is apply my command, which will be account ID will be 1 and create or activate. Thanks. What did I do? All right, so we're not going to fix that. I do have a finished demo, so from scratch it failed. I'll have to iterate and get better at that. But you get the idea, right? And so going to a microservice architecture, we actually need this functionality because we're going to need to make sure that our data is consistent across the architecture. Because there's no foreign key constraints between the microservices. So if you look at the domain graph here, I have a shipment that's connected to an address. That's going to be the ship from address. I also have inventory that's going to relate to that shipment. Now, this is an entire domain, but the microservices themselves, they're going to have just a portion of this domain. And so when you split the monolith apart, you're going to have to split up this data as well. And there's going to be foreign key relationships that span across these boundaries. And so you've seen this type of diagram before. This is an entity relationship diagram. And typically when we create a schema in a database, we're going to have foreign key constraints. So in the monolith itself, we have this problem where when we go to microservices, we're not ensuring these foreign key constraints. We now have split up the development across many separate, smaller applications, and they need to pass these events around with each other to be able to create a consistent state of the system. And so here's an example of an online store that I put together. I have a catalog service, an account service, inventory, shopping cart, and an order service. Now, for the checkout process, I'm going to contact the shopping cart. And then the shopping cart needs to contact the account service, catalog service, inventory service, and order service. Right? And so there's going to be this communication between these different applications, but they all need to have an understanding of what the current state of the system is. And so to do that, they need to process the events that are coming from each one of these objects. And so as we just created from scratch that account object, which would be the account service, whenever I apply a command to that object, it's going to generate that event. It's also going to send that along to these other microservices who are going to subscribe to it, and then it's going to take an action depending on what state its object is in. And so that's the basic idea here, is that each one of these applications are producers of these events, and they're also consumers. And they're going to maintain their portion of the domain graph by processing those events in order or replaying them, and it gives you a consistent view. So there's foreign key relationships that span the boundaries across these microservice databases, but they're implicit. They're not really there's no way to really maintain consistency directly with the databases, nor would you want to. Now, you could do distributed joins. So if you think about building microservices, when you read, let's say you wanted to create an order. That order is going to contain information for the account. Maybe it's the account number. It's also going to contain information from the product catalog and inventory. And so you really have this giant object, this aggregate, that's going to reference data where the system of truth is not on that microservice itself, it's somewhere else. And so the first thing that people do is they say, okay, I'm going to do a distributed join, which is I'm going to call all those other APIs every time there's a read, and I'm going to join together those objects that I get, and then I have my consistent object. Yes, it's consistent, but it will also bring your system to a crawl because of obvious reasons. Also, distributed transactions themselves would be the inverse, which is I'm going to orchestrate a distributed transaction with two-phase commit. You don't even want to approach that. The idea here is that you're going to have these series of these checkboxes, and you're going to take these series of operations, and once all of the checkboxes are filled, then you can actually commit it to the system. And each one of those checkboxes represents a different microservice, and that is very brittle. Rarely works. And so with microservices, we're going to have our system, or our domain, split up into bounded contexts. Now, each one of these circles here, that represents a domain object, but it also could represent an account service, for example, or individual microservice. And so let's say that we have, for each one of these colored regions, one application, one microservice, and they control a part of that domain. Now, internally, they can speak a different language, but externally, they need to expose a consistent language. So inside, let's say I have two microservices for the orange region there, which is the account context. I can speak an internal language that I'll never expose externally between those microservices. But when I go across that boundary into the order context, I need to speak a consistent language. And that prevents things like creating duplicate names for objects across the organization. This is a very simple domain, but if you can imagine a larger domain with hundreds of objects, it's very easy to run into a uniqueness constraint. And so that's the basic idea. But how we do this performantly is that we create materialized views using an event source system. So going all the way back to what I said about the chip log, what we're going to do is we're going to wind that reel in, and we're going to take these events and we're going to create one materialized view instead of doing a distributed join. So here in this architecture, I have a friend of a friend application, which is kind of like Facebook. I have a friend service that's responsible for keeping track of relationships between friends. So if I friend Billy, for instance, I will store the ID of myself and the ID of Billy in the friend service. And then I have a user service, which actually just stores the user itself and the status of the user. In this example, it says RabbitMQ, but I'm using Kafka. And then finally, there's an event processor that's going to listen to all those events, and it's going to create one consistent view. I'm going to go forward a bit. We'll come back to this. All right, so CQRS is this idea that we can have these commands on these domain objects, and when I trigger those commands, it's going to change the state of the system, but it's also going to generate an event. So each command at least generates one event. So for the example of the account again, going back to it, we're going to have a read side, and we're going to have a write side. And a lot of people say that CQRS is really for performance reasons. It actually started out that way, but now it's actually a way to do event sourcing as well, and so there's some confusion there. Event sourcing and CQRS are separate things entirely, and CQRS is used for performance reasons to create materialized views, but also it critically solves this data consistency problem with microservices. And so you're going to have a write side and you're going to have a read side. The right side is going to take in a command model, right? So on the left side here, I have suspend account, and I'm going to then update the status, which we saw in this from scratch application. And then I'm going to create a model, and that model is going to be a read model. I'm never going to write to it. And so you can create this as many separate applications or as a monolith. I'm going to show you what you could do if you had unlimited resources, and you could create a command side and a query side. So the command side here is going to be all of my commands for the account, and it's going to output an event to Apache Kafka in order. So commands are going to generate events. And then I'm going to have an event processor that's going to pick up that event, and it's going to then write out the model to the read side, which can just be a regular data store, a relational database like MySQL. And I'll have a query service that exposes the API for reading these objects. And I can scale these differently. So if I have more reads, which I'm always going to have, than writes, then I can scale these differently. And then I can slap an API gateway on top of all of it and make it all seem like one application. And then the front end is only going to go through that API gateway. They're not going to need to know about the implementation details underneath. All right, so now with Apache Kafka, I explained a little bit about how that works. It's going to provide us with this abstraction for our event log, as well as being able to create these materialized views. So we can create a snapshot of this data, store it directly in Apache Kafka, and then we can actually pull it back. So I created an example that uses Spring Data Neo4j. So going back to this idea of friend relationships between users, this is actually the most complex example that I could think of in terms of relationships. So if you want to think about doing a distributed read in this scenario, it's impossible. Because let's say that you wanted to find a friend of a friend, and you only had basically a CRUD API that could look up a user and that user's friends. So then you would have to get all of a user's friends, and then you would have to issue a read for each one of those users' friends, and then you'd have to do a join to figure out friend of a friend. And so that's just not going to happen with most friend. My friend network is pretty small, so I think it'll be fine. But I think most people, if they have 100 friends and those people have 100 friends, you're talking about a lot of reads. And so I put a sample application together that's on GitHub, and we're going to run it. And what I did is I broke this down into two types of microservices. You have your domain services, and then you have your aggregate services. And so here's the architecture. And so we'll have that friend service here to the left, and that's going to track the friend relationships between users. And then the user service is going to just maintain the user object. Now, a user could be suspended, it could be activated, so it's going to worry about that. And then the friend service is just going to worry about its part of the domain, which is, can I be your friend? And then I have an aggregate service. This picks up all events, so whenever I create a user, whenever I add a friend, those events are going to be picked up by this Spring Boot application, and it's going to create a single view of all of this domain data across these separate services. So I have my domain service itself, and that's going to, we know what that's going to do. It's going to store friends. The aggregate service is going to create a consistent view. And so I like this idea of being able to look at your microservices as either domain services or aggregate services. You'll also have platform services if you're building a cloud-native application. Those are going to be things that Rob typically builds and maintains, like security for users and relay tokens to your microservices. But for this application, I'm just going to have my aggregate services and my domain services. So the domain services are going to manage the storage of domain data that it owns. It's going to produce an API contract for the domain data. And it's going to produce events when the state of any of the domain data changes. And then it'll maintain relationship integrity to domain data owned by other services. And then the aggregate service is going to solve that distributed read problem. And so I'll be able to find my friend of a friend or any other analytical queries by looking at one consistent view of all of the data that's created across my separate microservices. And so I have this application running. So we're just going to walk through the code. And so I have way more than just the 3. Actually, I think I have 5. And so I have my aggregate service. That's going to be the reporting view. It's going to join the data together. And so we can actually do our reads from there. And that's going to use Neo4j. I have a discovery service. Since this is microservice architecture, these applications are going to need to talk to each other. I have an edge service, which is going to be my API gateway. That's going to hide the nasty implementation details down beneath it. And then I have my friend service. That's going to track my friends, and that's a domain service. And then my user service. And so I have this running, but let's go ahead and look at the code first. And so let's look at the user service. Much simpler. So I have my event type. User created, very simple. My user object itself is just first name and last name. Then I have my user controller. So here you can see that I'm injecting in the user repository. And my source is going to be what I use for Spring Cloud Stream to pass messages between the services. And that's just using the framework itself. And so who's using Spring Cloud Stream today? Just curious. It's great. All right, so user repository, just a basic JPA repository. And let's re-add this. Now, what I do with Spring Cloud Stream is I'm just going to configure my, my stream object. So this is going to be a source. That means that it's going to generate events. And so I'm enabling the binding on this, and that's all I have to do. Now I can start using that object. I have to make sure that I configure it. If I go to my application YAML here, you can see that in the Docker Compose application that I start up, it's going to have a profile called Docker, and it's going to then load in the connection string details, and I'll be able to connect to Kafka and Zookeeper. Now I can switch this out with RabbitMQ if I change the binder. But I'm not going to do that. All right, so that's the user service. And the friend service, it does something very similar. It's just going to keep track of the friends of a user. So it basically takes in a user ID of one user and then a user ID of the second user, and it's going to create a Neo4j graph from that. It's a bit more complicated when it comes to the command. So if we look at the friend controller, you can see that since it's a listener, it's listening for these events, and it's combining them together. In this case, it's not. It's, yeah, so I can get my friends, and when I get my friends, I'm going to get a user ID. That's going to pull back the friends that are in the database. And for the add friend command, here's the URL. So I will go to /users, user ID, and then commands add friend, and then I will provide just the ID of the friend, not the object. And we kind of looked at this earlier, except it's a little cleaner. And then remove friend, much of the same, so it's going to just remove the friend. And so it's actually going to, I believe, talk to the user service just to make sure that these friends exist. when it creates them. And then the interesting service here is the aggregate service, and that's going to create one consistent replicated view of all of the data across the domain. And so you'll have your friend graph. And so it has the types for the friend and the types for the user. And it also has a friend processor, which is going to be a sink, which is going to take in the events that are generated by the friend service, and it's going to maintain its view, its materialized view from those events. And so here's the stream listener, where I have my sink, and I'm going to then process that event by getting the payload, getting the event type. In the case that it's a friend added, then I'm going to go ahead and save that relationship, and then friend remove just the inverse. All right, so that's it. I'm going to go ahead and start this up. I think it's already started. Yeah.
How does it do like hacking and all that stuff if like one of the services went down receiving these events? Is that taken care of by Kafka automatically, or?
Yeah, it would be.
Or if you have multiple nodes, is only one of them going to receive the event? Or is it?
So for this example, with Kafka, you can actually use case streams and you can replay events. So if you want to think about an eventually consistent system with the acts on the messages themselves, that's really just going to catch you up to the current state. And so if they had not been processed yet, then they will be processed when the application comes back online. But also, let's assume that you're creating a reporting application and you're creating it like 10 years after you've actually had the system running. You can go back to the beginning of that log and then replay those in order to the current one and then begin processing.
And you can make it so that if you have like a cluster, like 10 instances of the same microservice, only one of the nodes is receiving the events and it distributes them amongst those nodes properly.
Yeah, the concurrency. Yeah, you can configure that.
Okay.
Quick question.
Yeah.
So instead of storing the event type, could you have a stream per event type instead? So basically have a customer updated, customer created, separated that way? I mean, is that an alternate way? Is there one better than the other?
Yeah, absolutely, you can do that. Jakob, who built a fully event source system from scratch on stage at Spring 1, he did it that way. So what he would do is he would have the event types as a string, and he would map that to actual classes, which would be the events. Yeah. All right, so I'm going to try and start this bad boy up. All right, PS. Up. We shall see. All right, so let's see if Eureka's up. All right, so yeah, here's Eureka. So our discovery service, so you can see that the aggregate service is running. The edge service, friend service, user service. Great. All right, so since I have an API gateway, I don't have to worry about going directly to the friend service or the user service. And that's going to be 192.168. Cool. All right, so that's up and running. And so I'm just going to go to a REST client here. So the first thing I'm going to do is I'm going to create a user. And so that's going to be, if we can get the routes here, should tell us. Thanks, Rob. Users, post. Cool. All right, so that's the right endpoint. And it's going to be JSON, so the user is going to be first name, Rob, last name, Winch. All right, so I've created Rob, and Rob and I are going to be friends, so I need to create myself. Cool. All right, so I've created myself, and I've created Rob. I think I can get all users just to make sure. So we can see both users were created. And now I can actually add friends. But before I do that, I think if we go to the logs, should be able to see the aggregate service pick up the messages if Kafka is indeed running. And if it's not running, then of course it's not going to work. But an easy way to see that is, yeah, so Kafka is definitely not working. But just to verify it, there is a database that the aggregate service is using, and that's Neo4j. So we can actually go there, and I can see that there is no data. And so I need to recreate Kafka because of the network stuff. So I started this up before, and then I changed the network, so let's kill it. All right, so while that's starting, let's go ahead and look at the Docker Compose file. All right, so for Kafka, I'm going to just include what Confluent has for Docker. So this is Docker Compose version 2 file. So it defines the services. Here's Zookeeper, and it's going to be a part of the microservices network. And then here's Kafka. Kafka needs to have Zookeeper start up first, so it says depends on Zookeeper. And I set some environment variables. And then I have Neo4j, and I'm going to expose to port 7474. I have my discovery service, which is using Eureka. And then my aggregate service, that's going to depend on Neo4j, Kafka, Zookeeper, and the discovery service. The user service, much the same. It's going to depend on Kafka and Zookeeper and discovery service, and then the same thing for the friend service. And then my API gateway is going to be at port 9000. Any questions while we're waiting for Eureka?
Would you say it's bad practice to have shared domain objects across, the different projects if they're all, especially if you're versioning your APIs? So, you got fringe users, let's say you're on version 1.
Yeah.
Right, so, one perspective is you have parallel class hierarchies across them. Another would be to have a common jar. I've read, both ways,
Yes, so let's look at a diagram here. Yeah, so looking at this, kind of re-describe that question with objects.
So, right, so here the order is shared, right? That's the boundary object, yeah. So the objects that are shared, separating those out into like a separate project or separate jar file and sharing those across, the...
Oh, sharing libraries themselves. No, I would recommend not doing that. So that's where a lot of people got in trouble with the SOA, is that they had these global libraries with types of the objects, and what ended up happening is that you would have to update a set of objects every time you made a change, which meant that you had a coordinated release, and so you don't want to do that. I think I have a slide in here that shows you that, but it may not. I think I deleted it. Yeah. Yeah, so here in this example, I have the accounting service, inventory, and shipping, and there's the domain there at the bottom. Now, each one of these services are different applications, and they're sharing libraries of this domain beneath. But the accounting service itself kind of owns the customer and account object because the other applications don't need it. But as the other applications, the requirements increase, they're going to need to use these objects, and they're going to need to use a certain version of it. And so you see for the address record. Now let's say that one of these services, the inventory service, requires an update to the address record. Now you have to go and update that on the other services as well to make sure there's no breaking change. And typically this is done every quarter in a quarterly release schedule, and it just becomes an absolute mess. And so then every quarter you're having to make sure that you deploy all the applications at the same time, and it becomes a distributed monolith, which is not very fun. And so the idea then, you would want to probably document your APIs. Let's say that I'm a developer for a Twitter application. I can go to the Twitter API. I can actually see what those objects look like. I can see what their fields are. They might have a sample application that has a client. That's the current version. And then they have a version of previous versions. And so that's probably a better approach than having to worry about ownership across all of these different microservices and publishing one versioned API. Because then that's going to run your schedule. And you don't want that to happen, especially if you have like 400 microservices eventually, which is the case of Netflix. Actually, John could probably speak to that. I don't know if it's 600? Thousands, right, yeah. And did you have that problem at Netflix with the types shared across the microservices, the libraries for the domain? Like sharing the classes themselves for your domain objects. Like having some global library that has a customer object, account, address, and all of their fields. Okay.
And I guess what I'm talking about is like, you have your service jar, and then offering just for convenience purposes within the, let's say within the black box microservice architecture, right? So if you just want to call it middleware. So offering 3 jars, the service jar, a client jar, and then like a domain context jar, right? So it's like if you're on version 1, of the service, instead of having 50 different clients having the code REST templates over and over and over, right? Just giving them a jar for that version.
Yeah, if you're producing it from each one of your microservices,
that's what I'm saying.
Yeah, totally fine.
Okay.
Yeah.
Sorry, I need to clarify that.
Yeah. Just
so
don't.
I'm not talking about a massive domain shared object model. I'm talking about, and I'm calling it bounded context model for that service. So I don't know if that's exactly correct, but that's kind of the practice we have, having 3 major types of jars.
Yeah.
And actually, when we do the Spring Cloud stream, we've got like a hub and an edge. We split those up. So.
As long as when your microservice updates that, it doesn't cause all of its consumers to have to update with it. Like if it goes to production and has a breaking change because the consumers haven't updated their versions, like that's probably a bad idea. Yeah. Cool. I think this should be running now. Hopefully. Okay, so let's try this again. Thank you for being patient and not throwing tomatoes. Body. All right, so we should be able to see. Yeah, aggregate service didn't want to pick it up. So, I'm not sure why. But I think you guys get the point, and hopefully at some point in the future, I could do this again and everything will work. I'm definitely going to work harder at it. But if I go back to Neo4j just to test one more time, yeah, so it didn't pick it up. So typically what would happen is that if everything was working and Kafka did get that message, then you would have the aggregate service pick up that event and then process it and create a replicated view of all these objects in Neo4j. And then I could query Neo4j itself to get a friend of a friend rather than having to go directly through each one of the different applications. So I think that's it. So yeah, thank you guys. Questions?
So, like broadly speaking, like how do you view like storage? Because that's another thing is that storage will take up a lot just in a typical database, but then necessarily this will require even more storage since you're not just storing the final state of it, you're storing all previous states. So, like what are general strategies around that? Have you seen like 24 hours before you take an event out of Kafka or like?
Yeah, so it depends. And so Kafka has something called log compaction. So it can compact the set of events into one. And if you look at the state machine of an object, there are certain things that reset the state of the graph. So if you go from pending to activated, you'll never go back to pending. So all pending events are going to, you're not going to need to store those. And so there's some kind of cycle in these graphs, these state machines, where you can actually say, I can compact that because like even if I go back and replay it, I'll still arrive at the same state, right? So you can ignore those events. And so there's just different strategies you can use. Kafka should handle anything you throw at it at scale. So it should not be a problem. I've heard of just an enormous velocity of events with some of Pivotal's customers. And what they'll do is they'll define cold events versus hot events, which is given a certain amount of time, they'll snapshot and throw everything else away, or put that in cold storage, which will be used for HDFS. And then they can still use things like Apache Spark on that data, but it's not going to be operational. Any other questions?
Any thoughts on JSON versus Avro? I mean, do you have experience with Avro?
Not too much. So I know the theory behind it, and one of the things that I'm missing here that I really need to talk about is the schema evolution of these messages. So when you're talking about a microservice architecture, like this is probably the biggest problem that you're going to have is worrying about schema evolution. Whenever a microservice needs to change the schema of an event, which is going to often happen, since you're replaying from the beginning, you're going to have these different versions. And so you're going to need to make sure that all of your consumers have a history of the evolution of that schema as well. So as they replay that log, they won't run into any issues.
And actually, just kind of going back a little bit to question he asked earlier about having maybe event types versus different streams or stuff. Like, I mean, is it just, six one way half a dozen the other versus those two, or is there real trade-offs between them that you know of?
Sorry, say that first part again?
So instead of having like an account event type and a customer event type and stuff like that, you just have like a customer stream and an account stream. Do you know, like, is there real trade-offs between those two? Like, or is it just, kind of preference or?
So with Kafka streams, it gets really, really interesting with being able to join streams. And so they have an entire DSL for being able to look up the customer stream, the account stream, and then you can have foreign key relationships in the stream. So you can actually create one consistent object just from the streams themselves. And so there's a lot of cool things that you can do with that API.
Okay.
Yeah, and I think my example, I was talking about like not just a customer stream, but like a customer created, customer updated.
Yeah,
customer kind of more along that.
Yeah, that's why, yeah.
Yeah.
But you were talking earlier, yeah, that's perfectly valid as well.
Yeah. Just for your aggregate objects, your domain objects, if you just have a status field in it, you can just track the evolution of state from that status field. But you can also get more granular. You can actually, whenever you change anything, any part of that field, let's say it's not really a command, but you're updating maybe the name of the user, you can actually store that as an event as well. I think that's probably too much for most people. Really what you want to make sure of is that you track the status of these objects and how they change, because that's going to give you the behavior, and also most of the business logic is going to run off of that. It's not going to really run off of the name of a user. It's going to run off of what status they're in. So if they're activated, if they're suspended, that's more important. Any other questions?
What are the big use cases for this besides like a materialized view for that distributed read, like keeping track of all those events?
Yeah, actually I have a slide for that. I skipped over. Yeah, so event stream processing is an interesting side effect that you get because as you build this event source system, you also can understand the behavior of all your users. And so here are the use cases. And so you can, of course, use the aggregates to get the consistent state of the entire system. It also provides you an audit trail, which you can replay. So we mentioned that. And event stream processing itself is being able to analyze the behavior of all of your users over time. So if you think about one stream of all of these state changes, it actually represents the actions of all these users. And you can use that to generate some interesting analytics in real time. And so you would use something like Spring Cloud Dataflow to process those events and then generate kind of like the log line reeling it in to see the speed of a ship. You could do that for your domain data. And then compensating transactions as well. If something goes wrong in an eventually consistent system, it's not guaranteed that it's going to arrive at some consistent terminal state. You might have a situation where you need human intervention. And so in an event source system, you can actually describe this state machine and you can describe failure scenarios. And so if these certain amount of events are processed in this order, that's going to issue a compensating transaction, which will remediate or talk to the other services and get them back to a consistent state by reversing what it did. So it'll append more events to, I guess, fix the system being in an inconsistent state.
That's one of the hardest problems we're trying to is when somebody calls one web service and calls three others, it changes data in all three.
Yeah.
What do you do if the third one fails? Right now we try compensating
Yep.
transactions. I don't know.
But yeah, so let's say that one of those application goes offline during the compensating transaction. If you don't have a microservice actually create a set of events that all of these services are going to process, if one of those applications goes down or the mediator goes down, you're going to be in an inconsistent state. And there's no way to go back and fix that automatically without doing something like polling, which is just you can't really do at some scale, which would just like constantly checking to see what the state of other services are just to maintain consistency. So yeah, you would need something like this so that your mediator would create that sequence of events in order, append it to the log, and then if anything goes down, when it comes back up, it can start from where it left off and continue to compensate. Any other questions? No, it's good. It's all good.
Can you go over a little bit more in depth on this idea of snapshotting you were talking about earlier? I mean, is that really just, having two stream listeners, right? And these events come in and like at the aggregator, right? So when you talk about snapshot, are you talking about reacting to user and friend events to kind of create an aggregate view, more of an operational view? Here's what it is now, or is it something else? I just want to make sure I understand.
So I like the use case for the friend graph because that's going to be an operational query that you're going to need in a social network. For instance, for Twitter, they have like people you should follow. These are queries that you're going to need to have for your front-end developers to be able to, I guess, complete these features. And so if you were to build that as a microservice architecture, it's impossible to be able to actually have that feature with just the user service and the friend service. So you need that reporting view, that consistent view you can run analytics on. And it's eventually consistent. And if you look at the features, they really tell you what's possible. Like you don't always need it to be consistent for friends you should follow, right? There's nothing that's really going to screw up the state of the system from there. And then the user probably doesn't even look at that stuff anyways. And so there's that.
So in this case, you're talking about the snapshot really is that aggregate service that's listening to user friend events, right?
Yeah.
And then basically aggregating that data, making it available via an API.
So the difference between materialized views and snapshots is that snapshots itself, that's a term that's used in the Apache Kafka Streams API. That'll allow you to replay a set of events and store a snapshot in Kafka. With materialized view, you're probably going to do the same thing, but in another database somewhere else. So let's say, in this case, I'm using Neo4j. That's more of the materialized view use case. And then for the Streams API, let's say that you wanted to create a snapshot as one microservice just from your own stream. Then you could also do that directly through Kafka. And that's more for performance reasons. Yeah. Like for the shopping cart here, so for the online store that I put together, I'm using event sourcing. I'm not using Kafka. So I did this from scratch, and there's 4 types of events. There's add item, remove item, clear cart, and checkout. So I'm actually not storing an object for the shopping cart. Whenever the user takes an action, it's going to relate to one of these events. And here's what the shopping cart actually looks like. And this is in a relational database. And so I have a timestamp created at last modified. And then I have the cart event type. That's going to be either add item or remove item in this case. I think 0 is add item. And so if you just walk through this, you can kind of logically come up with what that object's supposed to be. So the first event here is to add an item, and that's going to add the product ID SKU12464 with 2 of those items, and it's going to relate to user ID 0. And if you just play these in order, you're going to remove one of those items, and so you can come up with the current state of the shopping cart just from this set of events. Now, let's say that this is 1 million lines long. If you were to do that every read, that would be pretty expensive, right? So you would be reading from disk and actually having to run through each one of those objects to come up with a shopping cart. And so that's where you would want to snapshot it. So you only replay once and then go to the snapshot, grab that, instead of replaying again. Yeah. Cool. Any other questions? Okay. Thank you, guys. I appreciate your time. If you do have any questions, let's talk after. Thank you.